Hello friends, welcome back to our YouTube channel, VLSI for Freshers. In this video, we will discuss about physical design interview question for Synopsys. So in this video, you will get that idea what type of question Synopsys are being interviewed for physical design or STA role. So please go through the whole video. The first question is what are the guidelines need to place macros? So placing the macros, what guideline we need to follow? First guideline placement of macros are based on the fly line and place macros of same hierarchy together. It means which are the macros are hierarchy together, same hierarchy need to place. Otherwise, if we place far away, then will causing the timing violation. And net length or net delay will increase and net length is also increase, which causing the timing violation. Keep the sufficient channel spacing between the macros. To avoid congestion, keep the sufficient channel spacing between the macros. And macros that are communicating with ports of core, place them near to the core boundaries. Place macros around the boundary of core, leaving some space between macros to core edge. That will help in the when we inserting the buffer or inverter to fixing the timing violation at the route or ECU stage. So please place macros around the boundary or of core, leaving some spacing between macro to the core edge. Avoid the cross connection of macro placement. Avoiding the cross connection of macro placement. Avoid notches while placing the macros. There should not be any notches present while placing the macros. If it is unavoidable, then using the blockage. Keep the keep out margin around the macros. It will stop the pressing of standard cell around the macros. Keep the placement blockage. Consider the power strap while placing the macros. So these are the basic guidelines we need to follow while placing the macros. Now next question is what types of the floor plan? There are three types of the floor plan: abated or non-abated or a mix of both. In first one, there is no gap between the blocks. If you see the in first image, there is a block A, block B, block C, block D. But there is no space between, there is no gap between them, block. So this kind of floor plan is abated floor plan. And next one is non-abated. In this, there is a gap between the blocks. If you see, there is a small gap between A and B. There is a gap between C and D and A and D. There is some gap present between the bit of blocks. And next one is the mix of them. Mix of them means in which floor plan we have both. Some blocks having the gap or some blocks not having the gap. So these are kind of the floor plan we use. This kind of question which is asked in the Synopsys interviews. Now next question is what type of the placement blockage you use? So it means you have to explain what are the blockages you have used in your project. So there are hard blockage or soft blockage and partial blockage. What are the hard blockage? Hard blockage means block all the standard cell and buffer to be placed. It will block all standard cell and buffer to be placed in that area. And so blockage allows only buffer can be placed. Only buffer can be placed. And partial blockage, we can block standard cell as per requirement per value. By default, it will blockage factor is 100%. According to our need, we can change it. What percentage we can placing the standard cell 65% or 40%. By default factor is the 100%. This type of the blockage we used in the physical design. Next question is what to need we qualify for the floor plan. What is the floor plan qualification? So no macros should be overlapping. There should not be any notches. Remove all unnecessary placement blockage and routing blockage. If we have placed some blockages in this during the placement, we have to remove all unnecessary placement blockage we have placed. Minimize the total chip area. Routing should be easy. Check power grid correction. These are the basic qualifications which we need to do before going to the placement stage. Next question is level of power distribution in power planning. Means how the power is distributed across the chip. What are the levels? You have to explain all those levels. So first, there is a rings, power rings we called. It will carry the VDD and VHS around the chip. And then is stripe. It carries the VDD and VSS from ring across the chip. And rails. Rails connect VDD and VSS to the standard cell. Next is power wires. Insert all the power wires. Next one is stripes. Connect the ring to the power pad. So these are the levels of the power distribution in the power planning. This kind of interview question is asked during the interview for the physical design. And next question is what are the power reduction technique you use? Whatever the technique you use for reducing the power, you can tell. Now some power reduction techniques are clock gating, power gating, voltage and frequency scaling, multiple threshold voltages. These are the some basic techniques which we use for reduction the power. Now next question is how to fix EM violation. How will you fix EM violation? EM violation is electronic migration. So there are the some fixed method for the fixing the EM violation. Buffer insertion, downsize the driver, switching the net to the higher metal layer, adding more wires, increase the width of the wire. So these are the some basic techniques which we use to fix the EM violation while doing the physical design. Increase the width of the wire, adding more wires, switching the net to the higher metal layer, downsizing the driver, and buffer insertion. These are the basic techniques for using the fixing the violation, EM violation. What check we need to do after the power planning? Once the power planning is done, what check we need to do first? That our power planning is done in good or bad. First is all cells should get a power. Power DRCs. All the DRC related to the power. Acceptable IR drop. IR analysis we need to do. The static IR drop or the dynamic IR drop. If there is acceptable, then we can go to the next step. Now next question is, what are the goals of the placement stage? The placement stage goals we need to tell in this question. Minimum timing DRCs, minimum cell density and pin density, area and timing and power optimization. Placement should be routable. It means you should have the routable placement, which you can do the routing easily. And minimum congestion. Congestion is very important. You have the minimum congestion in the placement stage. Otherwise, when we go to the CTS stage, it will create the problem. Then again, you have to do the placement if the congestion is more. So please take care of the congestion. Acceptable congestion only we can go to the CTS stage. These are the goals of the placement we need to take care. The next question is what are the types of the placement? There are two types, coarse placement and legalization placement. The placement tool will determine in coarse placement, the placement tool will determine an approximate location for each cell according to the timing and the congestion. In course placement, tool will only determine the approximation location for each cell. But in the localization placement, the placement will move the cell to their localized location to avoid the overlap between the cells. These are the types of the placement. Placement method. When if we have the timing or congestion at the placement stage, then we use that placement method to remove the to decrease or minimize the timing or congestion. So we use for timing driven placement. It will define the placement based on the timing and congestion. And congestion driven placement tool tries to spread the cells where the density of cells are more. So there is a command we use in the ICC with congestion driven placement with the high efforts, in which the tool tries to spread the cell where the density of cells are more. It will focus more on the congestion. Tool will give more focus on the congestion, then it will help in reducing the congestion. So these are the types of the placement methods. Now next question is how to qualify for the placement. Once our placement is done, how we can our placement is qualified for the next stage or not. Check congestion. For check congestion, we do the use command report congestion. Check timing. Timing report we check. Timing report we check by doing report underscore timing. And congestion we do check report underscore congestion in the ICT2. Then we do the check utilization and do the check utilization in which report underscore utilization. Cell overlapping. There should not be any cell which is overlapping. Unplaced cell should be 0. So these are the basic checks we need to check before qualify for the placement or before going to the next step, that is CTS. So please. Next question is, what is the magnet placement? Magnet placement is specify the fixed object as a magnet and have the tools place all the standard cell connected to the object close to it. It is a magnet placement is a technique to improve our congestion and timing in a complex design, or we can use the magnet placement. The magnet placement is a technique to specify the fixed object as a magnet and have the tool place all standard cell connected to the magnet object close to it. We will, in magnet placement, we specify one object as a magnet. Then whatever the standard cell related to the object, tool will place a connected to magnet object close to it. Then it will improve our congestion and timing. So this is the important concept which you can expect in interview question. There is a one command place of in the ICC2. So what is this command actually do? So this command consists of 5 stages place of. If we run the place of command, then it will do all those 5 things one at a time. Initial course placement, HFN buffering, high fan out synthesis, initial optimization, final placement, final optimization. So these are all the steps done by this one command place of. Now some CTS related question. Goals of the CTS. What are the goals of synthesis? Synthesis. Now our main goal is minimum skew and minimum insertion delay. Now next is max trunk voltage, maximum capacitance, maximum fan out. So these are the goals of the CTS we need to take care. What are the difference between normal buffer and clock buffer? There is one normal buffer and one is clock buffer. What are the difference between? Clock buffer have equal rise time and fall time, and normal buffer may not have equal rise time and fall time. Clock buffer are usually designed in such a way that input signal with 50% duty cycle produce the output signal with 50% output duty cycle. So clock buffer are usually designed in such a way that input signal duty cycle is also 50% and produce the output signal with the 50% duty cycle. So these are the very main difference between the normal buffer and clock buffer. What are the NDR rules? NDR rules are applied to reduce the clock and EM violation. Apply NDR for clock nets. Basic NDR rules are double spacing, double width building. So these are the some non-default routing rules we need to take for fixing the crosstalk and EM violation. We use the NDR rule. Effect of CTS. While doing the CTS, some crosstalk loss will come. Congestion may increase due to the clock buffers are added. Congestion will increase before we adding the buffers to balance the clock tree. To minimize this skew, we adding the buffer. Congestion may increase. Now, what is useful skew? When clock skew is intentionally added to meet the timing, then we called it the useful skew. So useful skew is basically we added the intentionally in the path to fixing the timing. What are the CTS algorithm? One is S-tree algorithm, S-tree algorithm, method of mean and median, pi configuration, geometric matching algorithm. So these are the CTS algorithm which tool used for building the CTS tree or clock tree. Now we'll go to some routing question. Goals of the routing. No DRC error. No LBS. Minimum total wire length. Minimum routing area. Meeting the timing DRC. Minimizing the congestion hotspot. So these are the basic goals of our routing. Steps in the routing flow. There are four stages in the routing: global routing, track assignment, detailed routing, search and repair. These are the 4 steps in the routing stage. In global routing, what happens? Define the routing region. It generated tentative route for each net, and each net is assigned to the set of routing region. Routing region are those of which an interconnected wire are laid out. So global routing assigns net to the specified G cells, but it does not specify the specified track for each of them. Each G cell has finite number of horizontal and vertical tracks, and it does not specify the actual layout of wires. In global routing, it will happen. Now next stage is track assignment. Track assignment, it is the stage where the routing track are assigned for each global route, and tracks are assigned in vertical and horizontal direction. And number of routing layers that are available depend on the design also, and if the die size is more greater than the routing track. Track assignment replaces all global routes with the actual metal layer. So there will be many DRC and signal integrity and timing violation will come. Now next is detailed routing. In detailed routing, in this stage, the actual connection between all net takes place. It creates the actual wire metal connection. It specifies the track for interconnection. Each layer has its own routing grid rules. The detailed routing starts with routing dividing the block into specific area called switch box or S box, which are generally expressed in terms of G cells. And these boxes are aligned with the G cells boundary. Objective of detailed routing is to minimize the total area wire length and meeting the timing constraint. Now next is search and repair. Search and repair, it is performed during the detailed routing after the first decision if there is any floats and DRC violation. So in search and repair, floats and space violation are fixed. These are the routing stages in the routing flow. Next question is, what is cloning and buffering? So cloning, it is a method of the optimization that decreases the load of the heavily loaded cell by replicating the cells. And buffering is the method of optimization that is used to insert the buffer in the high fan-out net to decrease the delay. So in cloning, what will happen? It will decrease the load of the heavily loaded cell by replicating the same cell. And in buffering, we insert the buffer in high fan-out net to decrease the delay. So this is the cloning and the buffering. Now, what does the SDC constraint file contain? So SDC is Synopsys design constraint, in which we all give the design related constraint. Types of the information is present in the SDC. Operating condition is present, timing constraint, area related constraint, timing exception like false path, design rule constraint, wire load model, multi-voltage and power optimization constraint. So these are all the constraints present in the SDC file. So next question is, what are the ST inputs and outputs? In ST tool, what we give the input and what we get as output. So we give netlist as input to the ST tool, library.lib file, design constraint, SDSF, step file, parasitic data, and timing reports we get. We get the timing report to the report timing in the ICC or PT cell. These are the basic input and output for the requirement for the STA tools. What is clock jitter? Jitter is the short-term variation in the signal with respect to its idle position in time. It is a small deviation from its idle position. It's called a jitter. If the clock period is like this, and if we are getting like this, it will displace from its original location. So it is called we call it as a jitter. That's one is displaced from its idle position. And next question is, why multi-bit flow is used? Multi-bit flip-flop has many advantages due to its architecture over the single bit flip-flop. Area reduction, power reduction, timing improvement, better clock skew control. So these are some basic advantages of multi-bit flip-flop over the single bit flip-flop. What is latch-up in CMOS design? Latch-up issue can be defined as the formation of a direct path between the VDS to VGS in design. This causes the high current flow between the power and the ground. Latchup is a phenomenon in which the formation of a direct path between the VDA and DTS. Due to this, a huge amount of current will flow between the power and the ground. This is called latchup. How to fix latchup? So you can fix using the tap cells, guard ring, isolation trunk, epitaxy layer. In physical design, to fix the latchup, we use the tap cells. So these are the some fixing methods which we use to fix the latchup. So these are the some basic questions which is asked in the Synopsys interview question for physical design or STA profile or for application engineer position. In next part, we will discuss about more question related to the timing or more difficult question in physical design related we will discuss. Thanks for watching. Please like, share and subscribe our YouTube channel vlsi4freshers for more updates. In next part, we will discuss more questions. Thanks for watching.